So we're starting by finishing this chart that we started yesterday in class. These are with the seismograms, which are those little squiggly lines. Remember that these squiggly lines tell you when the P and when the S waves arrive. Essentially, let me get a copy of one of them. Essentially, these are the exact same thing that we've been doing the whole time on these half sheets of paper. The 5 questions like the one we did yesterday. They're essentially the same question as this one that we did yesterday. So it's really asking how far away is the epicenter? If the P wave arrived here and the S wave arrived here, the only thing that's different now is instead of me telling you, okay, it arrived at 2:35:22 and 2:42:37, what you have to do now is read that arrival time straight off of this squiggly line seismogram thing. So to do this, the first thing you're going to have to look at every time you do one of these is the scale. The scale will always be different on every one of these, and that's how they try to trick you. On this one, it tells you the time scale is in minutes after noon. So this one is 0 minutes after noon, which means it's exactly noon. Then 12:01, 2, 3, all the way to 12:15. So before you can tell me the difference in arrival time, you do need to be able to tell me when they each got there. So when they arrived. To do that, it's simply, and we did the first one together yesterday. So why don't I do the station Y? So the P arrived right at 12:04 and 0 seconds, and the S arrives right at 12:08 and 0 seconds. So that one's pretty easy to do that math. What's the difference there? Yeah, 4 minutes. Sorry, I couldn't hear you. That math's easy. Now, what you might have noticed, and if you had read the directions, on this one, it was possible to just count the differences because they went up by ones. So you can see here's 1 minute, 2 minutes, 3 minutes, 4 minutes. There's 4 minutes in between each station, each arrival time. It's not always that easy. And I'm going to show you the one that's on your lab so you can see that it's a little different in lab. This one was very similar. So the P arrived at 12:03. The S arrives at 12:06. So that's a difference of 3 minutes. And I believe we did this one together yesterday. That should have been a difference of 1 minute and 30 seconds. And now you just continue on just like we've been doing again on these half sheets. Like yesterday when we had a difference of 7 minutes and 15 seconds, you then took that information to your reference table and did the same thing we've been doing for what is it, weeks now? So just to refresh your memory with this one, we'll do the 4 minutes. Oh, I already had mine done. There we go. So one thing, especially when you have 3 of these, one thing I do just to save myself some time is I marked all those differences right away. So I marked off the 0, I marked off the 1:30, that was for station X. Station Y was 4 minutes and station Z was 3 minutes. That's one thing you could do to save yourself some time. Just one thing that I want to caution you is make sure you write the right information for each station. So then you go up until you find where it fits. I found the first one right at 800. The second one, I did this already. I had 2,500. And then 1,700. Do you guys agree with that? Or does somebody need me to show who didn't get those answers? How about that? Should we go through one? What? Oh yeah, 100 off it. 100 off is basically saying you're perfect. 200 is close enough. But if you're off by 200 on every single one, let's figure out what's going on that every single one's 200. But 100, consider yourself perfect. Higher or lower. Are there, can I ask what you did wrong? Do you know what you did wrong? Just so I know what people do wrong. Or didn't you do it wrong? Yeah.
Oh, I switched the number.
Got it. That'll do it. Anybody else have, because I just like to get into the heads of my students. What did you guys do wrong on these? Or do you not know yet? All right, we're good with them? Now, how about the travel time? Do you guys remember how to do that part? Because it's worded weird here. You don't use your scrap paper, but what distance do I use? Yeah, that one right there. So we know that the distance to the epicenter is 800 kilometers. So we need to figure out, well, how long does it take for a P wave to go 800 or 2,500 or 1,700? So again, going back to your reference table, this is stuff we've been doing since day one. Here's 800, go up till you hit the P wave, go over. I got 1 minute and 50 seconds for that one. You did that wrong? Did you do scrap paper stuff?
No, I read it all.
Oh, that's another thing I've seen people do is, this is your arrival time. Is that what you wrote? You wrote the 12:01:30 or whatever it was, 12:01. That's the arrival time. That's what time it arrived. I want the travel time. Does anybody need some time to fix these? How many people did it wrong? Let's do it that way. Okay, take a minute. Everybody look over your answer. See if you need some time to fix those travel times now that you see how to do it. So take a minute and figure out those travel times. And this is where I'm thinking it gets to be the hardest thing you're going to do all year because you know how to do everything. But when you go to actually do it, you do the wrong thing. All right, so when I went through, so I already got 1 minute 50 seconds for the P wave, and I got 3 minutes and 20 seconds for the S wave to travel 800. Do you guys agree? Okay, great. Over here to travel, yeah.
Didn't you just add the difference of travel time to the wave?
Yes, there are tricks to this. I don't talk about the tricks because I don't like doing that because that leads for one more place to make a mistake. So if you had made a mistake here or adding, which we all know some of us are not the great adders. I hate extra places to make mistakes, but if you want to do it, go for it. I just don't talk about it. Then again, so 2,500, which is here, you go up till you hit the P wave, go over. I got 4 minutes and 50 seconds for the P wave and 8 minutes and 50 seconds for the S wave. Are you within 10 seconds of me? And then finally 3:30. And is it 6:20? You guys agree? No? Yes, no? Does my math not math? My math didn't math. So that's, did you guys get a different, let's see, where did I go wrong? 1,000, you got the same? Okay. TJ's probably right because they don't math right, but that's okay. So yep, I got 3:30 and oh, okay, so 3:30 and 6:30. Let me just double check this one. Yeah, I guess this one, it really depends. Like right there, 6:20 is probably not quite halfway. That's why they give you 10 seconds. That one's fine. Either you could have done 6:30 or 6:20. I do see either answer working. So this is kind of the how we put it all together. Everything we've done for the last 3 weeks, all put in one question. How do you feel about it? we're gonna practice it more and more. I know it's gonna get kind of old again, but just to kind of solidify what we did yesterday, let's grab your homework, which was page 25. Let's see how you did on your time math. Okay, I did these answers somewhere, but yeah, we have 3 different packets going here today. So I know we did a bunch of these together. All right, let's just go through them. And if you need me to go over any, I can. Starting with number 1, no borrowing required. That was 1 minute and 25 seconds. Number 2, no borrowing required, 20 minutes. Number 3, we did together. You had to borrow with that one. That was just 50 seconds. And number 4, again, no borrowing required, just a minute difference. Number 5 is 1:27. Number 6 is 2 minutes and 38 seconds. Number 7, I believe we did together, and you should have gotten 9 minutes and 43 seconds. Yeah.
No.
For what one? Yeah, well, you did that one wrong then. We did that one together in class yesterday. We did. I'll walk you through it. So you can't do 17 minus 34, so you have to borrow. So we changed this to 4. You borrowed 1 minute, so that's 60 seconds. You already had 17. 17 and 60 is 77. And 77 minus 40, or 77 minus 34 is 43. Again, you can use your calculator for that. Now we try to do 4 minus 55, which you cannot do. So you have to borrow one of the hours. You already have one, or you borrowed 1 hour. That's 60 minutes. There was already 4 there. So this changes to 64. 64 minus 55 is 9. If you got 11 there, you probably just did your regular normal math wrong, which is why I hate when people do math in their head. Okay, so again, you just did your math wrong. It's the simple math that you guys are getting wrong. Suck it up and use a calculator. I promise I won't tell your 2nd grade teacher you don't know your math. Yeah, we'll get there. Sorry. 47, you guys good with that one? Anybody need me to do that one together? 58, 59, this one required a bunch of borrowing. Do I need to go through that one? Few people. Cam, you want me to go through that one, or you skipped ahead to a different one? 31, 52. 155, 38. And guys, if you think I'm wrong, let me know, because I literally just did this myself this morning and I'm not perfect. 204. Is that the one you wanted to go over, Serenity? Was it that one or this one? Oh, yeah. I think I just stopped working. Sorry. 36, 12, 45, 45. I did again. Hey guys, don't do this in a hurry. You gotta finish your math. 6, 58, 59, and 10, 22, 55. Okay. Will you ever have to do 16 of these again? No. But if you, right. So they will pop up in yeah, in your packet, I did include another page. We're not doing that next page. If you could do 16 of them, you don't need to do 16 more. What might happen, which you'll see pop up in lab, is you might need to, when you have 3 stations like you did, what we just did this morning, one of them you might have to subtract weird. 2 of them might be easy subtracting. 1 of them might be the weird with the bigger, the smaller number on top, and you have to borrow. So do I think you're going to need this? Probably not, but I did want to make sure you knew how to do it, because subtracting time can be weird and it can throw off your whole answer. All right, so there is literally one thing left with earthquakes. And that is taking all the information that you have about the earthquake and telling me the name of the city it happened in. But it's, again, a little weird and something you've never done. So to start this off on page 27, I kind of have a little scenario that does not involve earthquakes that will probably help you understand what we're going to do with earthquakes. So this scenario, I'm actually going to walk it through. I have it already set up on PowerPoint, so we'll do it here. All right. So we got a map of the United States here. And here's the story that I set up on page 27 for you. It says, are we there yet? Parents' most dreaded question. Yeah, are we there yet? Here's what this says. It says, imagine you don't know where you are. So you also have to imagine you don't have your cell phone, which that's a stretch for all of you, right? Having your, yeah, I mean, I can't handle that either. I'm not gonna lie, I'm there with you. All right, so you ask the first person you see. We're on page 27 if you're lost. It says you ask the first person you see who replies, you are 600 miles from Phoenix, Arizona. Okay, it's a weird reply because that's not how I would have answered you. Do you know where you are then if you're 600 miles from Phoenix? Where could you be? Anywhere 600 miles from Phoenix. So that means you could be, where the heck is Phoenix? You could be 600 miles north of Phoenix, or 600 miles south of Phoenix, or east or west, or literally anywhere in between. What does that mean? Where could you be around Phoenix? Yep, you could be just about anywhere. What if we did this and drew a circle around Phoenix that has a radius? Yep, making sure I'm using my right words. It's a radius of 600 kilometers or miles in this case. So this spot right there is 600 miles from Phoenix. This spot right there, or there, or there, anywhere on this circle is 600 miles from Phoenix. So do you know where you are yet? No idea. Do you know where you're not? Definitely not in Phoenix. We're not in Iowa. We're not in New York. We're not in a bunch of places, but we have narrowed it down. So we know, okay, we're somewhere on that circle. So that helps you a little bit. So you find this. So again, you ask where you are. You're 600 miles from Phoenix. You find this odd, but you look at your map and you come up with a number of possible locations anywhere on the circle. You decide to ask another person, and this person is just as annoying as the first person, and they tell you you're 710 miles from St. Paul, Minnesota. So what does that tell you? Okay, we're not in Minnesota. What you're going to do again is draw another circle. This circle has a radius of 710 miles around St. Paul. Have we narrowed it down at all? Narrowed it down a little more. Let me ask you, are you up here in New York? Why do we know we're not in New York? This spot here in New York, which is around us, is 710 miles from St. Paul. But we're too far from Phoenix. We're more than 600 miles from Phoenix. Good. What? Yes. There's actually only 2 places on this map we could be. Okay? And it's hard to see because my picture isn't perfect, but we could be, and you're right, both of them are in Colorado. Why did I put dots on those 2 spots? They touch each other. Those 2 spots that I just put dots on, they answer both questions. They are 600 miles from Phoenix and 710 miles from St. Paul. So we still don't know where you are, but you're closer. So again, you found this strange, but you add this bit of information to your map. Finally, you decided you need to ask one more person. This last gentleman adds you are 640 miles from Boise, Idaho. Aha! You know where you are. What city are you in? Okay, so what do we got to do? Need another circle. And that circle's going to be, what was it, 640? 640 from Boise. So we add that circle. And as you can see, and oh, now my dots have moved because it's a different slide, but can you tell where you are? Denver. Denver is the only place, yes,
Denver was actually my initial guess.
was it?
But
Denver,
I got.
you did a
I
little
did
rough
this with
estimate.
My fingers and you got Denver.
That's pretty, yeah. This one's pretty, because there was only one city labeled in Colorado, it kind of helped. But this is exactly what seismologists do with earthquakes. Just like that one that we just did with station X, Y, and Z at the beginning. We knew that the earthquake was 800 miles from station X, 250 from station Y, and 1,700 from station Z. They put that information onto a map just like this with the circles, and voila, they know exactly where that earthquake was. Now, do seismologists actually do that? No, there's a computer program that does that for them. But guess who gets to learn how to do that? It's not me, it's you. I already know how. All right, so just quickly, let's give this a shot. Let's see how you guys do with this information. So what we're gonna do is learn how to draw some circles. What do you guys need to draw circles? Compass. Now, one of your school supplies for math class is a compass. And I already saw a few of you whip yours out. That's super cool. But this is earth science and we have to be different and complicated. So we get to use these safety compasses. Apparently in math class, they trust you with sharp pointy objects. I'm not there yet. No, it's not me. It's actually the New York State Regents, because this is one of those concepts that you need an instrument or need to do hands-on stuff, like a lab. And in case you forgot, there's a lab final exam this year. So this is all things that might pop up on your final exam for labs. So you got to learn how to use the equipment New York State says you have to use. So some of you are getting brand spanking new ones of these. So if you do, please put the wrapper in the garbage for me. Okay, that one looks like a good spirit. Hold on to the spirit. Don't worry, they're not that bad. We're gonna spend the rest of today just practicing using these. I'll start with these are literally the cheapest, junkiest things you could ever buy. So that being said, they might already be broken. But the other thing I need to ask all of you that are like manhandling them right now, they literally cost 10 cents and you're gonna break them. And which isn't like a huge expense, but I don't have many spares. So please don't break them on me. If they break, they break, but be gentle with them. You guys are used to using the one. So here, let's do this so we can just practice drawing circles. Go ahead and completely close your packet. Is the back page blank? I think it is for everybody. Hey, Kim, can I borrow your sharp pointy one that you had? Yeah. Are they still sharp pointy or they come up with some? It's a sharp pointy one still. I would have thought they would not give you guys sharp pointy objects. I mean, come on, you're not all that most trusted humans in the world.
I need a move.
So you guys are used to compasses. You've all used ones that look like this. By the way, if you forgot, these are called compasses, not the ones where you tell your direction, but ones used for drawing perfect circles. Don't do that. So again, I know these look like fidget spinners. Please don't, because they will break. So you're used to the sharp, pointy compasses. And I hope you all know how to use the sharp, pointy one. So you put the point down and you loop around and you draw yourself a perfect circle. These actually work almost exactly the same. They actually, I think TJ, you said it too, they're almost a little bit easier if you've got one that works decent. So to start with, this part right here is called the bullseye. If you don't have a piece of plastic there, that's because yours is broken. Anybody missing the bullseye and has just an open hole there? Okay. It's a thing because as soon as they drop, they come apart. I can fix them. But if you're missing that piece of plastic, let me know because it's broken. That bullseye is the equivalent of the sharp pointy end of your regular compass. So that's the part that stays still. If you also notice, it's called a bullseye, and I don't know if I can make it pop up on the screen, but you can see the actual X that marks the dead smack center. That's the one that's going to go over whatever city that you're talking about. So if you were in that scenario and you were looking for Boise, Idaho, this bullseye goes right over Boise. What? Exactly. Just pull it out. You guys all, more than one of you pulled out your compass when I was going through those directions. So you joke, but a lot of you pulled out a compass, and I'm like, okay, just a bunch of nerds, but whatever. Now the pencil part is not stationary, just like this one opens and closes. So does this. So if you notice, this little blue knob turns. This is the part, by the way, that breaks all the time. So it turns, so you can open it up to however big you want. There are rulers on here, so inches and centimeters. We're gonna not use those when we're doing this because you're gonna use the scale that's on the map. But you can open it to however big you want and then turn it so that it locks in place. The locking in place is the part that doesn't always work. Are you guys able to get yours locked in place? Okay, if you can't get it locked in place, come grab a different one. And okay, I got it locked. So they do turn both ways, which is weird. It's not just righty-tighty. Sometimes it's lefty-tighty, which stinks, but whatever. So everybody got one that locks in place? All right, just to practice drawing circles, if you haven't already, you put the compass down. You put your finger on the bullseye. You stick your pen and or pencil in. Now notice there's two different holes. I don't like that there's two different holes, but there's two different holes so that you can either make a bigger circle or a smaller circle. For today, it doesn't matter which hole you use. But when we're actually measuring, it is important to remember which hole you measured with. We'll get there tomorrow. But anyway, you put your pinky, or not your pinky, I put my pointer finger, but you can use whatever finger you want. Hold down the bullseye. Do not let the bullseye move, just like you don't let the sharp pointy end on the regular compass move. Stick your pen in one of the holes and literally just drag it around your paper. And you should have a circle. For this, you might need to clear your desk of stuff. So if you've got your binder and your notebook and your phone and 18 other things on your desk, you might need to give yourself some space. So go ahead and draw yourself some circles of different sizes to get comfortable with it. Withdraw. Yes, so this requires some finesse. I kind of say you got to be gentle but firm, because if you're pushing down too hard, you're going to end up moving your paper too much. But if you don't push down enough, again, your paper might move out from underneath you. So you kind of got to get comfortable just practicing drawing circles. So unfortunately, those of you that are comfortable using your regular sharp pointy compasses, you do need to get comfortable using these compasses. Yes, I also find that ballpoint pens tend to work really well for this. Because they literally have that's why they're called ballpoint pen, is they have a ball. So they do slide a little bit better. Pencils, a lot of times people break the tips of their pencils in the while drawing the circle. Flare pens and gel pens work okay, but I also find they get stuck on the paper. So the only thing that we're going to just still talk about today is how big the compasses are going to open. So if you could just turn to page 39, we're not doing this today. Don't draw any circles on 39, okay? Because if you draw circles on 39, then we won't be able to do the activity. The last thing I want to show you is, yes, the compasses have the rulers on them. That's great if you are asked to draw a circle with a radius of 3 inches or 2 centimeters. But we're not in this class going to be doing inches or centimeters. We need to do miles or kilometers, which are always listed on the scale here at the bottom of a map. So when I say, in fact, let's do this. Why don't you guys open your compass to 2,000 kilometers? So let me show you the trick for doing this. So do you see how the bullseye kind of lines up with this 90-degree angle right here on the compass? I kind of call it the crack, but I don't know if that's an official term. So again, there's the bullseye. Here's what I'm talking about, that 90-degree angle, which would be 0 on both rulers. If you take that 0, so line up that 90-degree angle perfectly with your scale, then you can move your slidey thing until one of the, so notice the circles have pointers on the end of them here. So you're going to line one of those pointers up with the 2,000. Which one you line up, that's up to you. So for 2,000, you could either use the bigger one or the smaller one. It doesn't matter which one. So then you kind of got to figure out how to, 3 hands would work perfect for this, but you got to figure out how not to move your compass and leave the slidey thing exactly there while you turn your compass. I always recommend, once you think you've got it perfect, double check it. And then again, don't draw a circle today because we need this map for tomorrow. But now that I have this open, it stays there. So I don't have to worry about redoing it. The only thing I need you to pay attention to is, which hole did you use? Because if you go to draw your circle and you use this inside hole, but you measured with the outside hole, your circle is going to be too small, or vice versa. So what I always like to do is just double check, okay, I use the outside hole. It's a little weird, but you'll get used to it. We'll practice, but you are starting this in lab either today or tomorrow. No homework tonight. We are getting close to the test, so expect a test like Tuesday-ish, maybe Wednesday-ish next week. I will let you know later. No homework tonight.